Welcome. In this video, we are going to take a look at some problems involving the ideal gas law. This is what the ideal gas law looks like on your equation sheet, PV equals nRT. And I've also posted in here some other useful information that will help us as we're trying to apply this equation. So let's take a look at this problem right here. We're given some numbers and we're asked to find something. So just in general, a good problem-solving strategy in this type of scenario is to start by listing out things that you know. So we know we're given a pressure, and the pressure is 700 millimeters mercury. We're given a volume, which is 855 milliliters. We're given this degrees Celsius. That looks like a temperature. So that's 50 degrees Celsius. And then we are asked to find moles. So we are, you see a P, a V, a T, an N. This looks like a job for the ideal gas law, PV equals nRT. I want to rearrange it to solve for N. So I'm going to divide both sides by RT. There we go, those are going to cancel out. Boom, and I'm going to end up with this. N equals P times V over R times T. Now I just need to plug in these numbers. Notice I haven't identified R yet, so let's figure out what R is. We'll notice that there are, look on your equation sheet, there are 3 different values of R given. And what we want to look for is we want to choose the R value whose units match the pressure that we're given. So we're given millimeters mercury. None of these R values have millimeters mercury in them, but notice right here, in this little conversion here, it looks like a millimeters mercury is the same as torr. Looks like those two things are equivalent. So if we say something 700 millimeters mercury, that means it's 700 torr. So pressure is one of those weird things. There's lots of different units we could use to measure them. So it's in torr. So great. That means we should use this R value right here. So our R value is 62.36 liters times torr divided by moles times Kelvin. That's how we want to interpret these units here. Remember, if you see an inverse exponent, that means it's on the bottom. So as I'm looking at these units here, I want to make sure that in order for this math to work out right here, I need to make sure my units match up. So notice how my R value has volume in liters, and this right here has my R value in milliliters. So I need to convert my milliliters to liters. So there's 1,000 milliliters in a liter. So I need to make sure my volume is in liters in order to use this equation. Also notice that this bottom K, that is Kelvin. Right now my temperature is being given in Celsius. So I need to convert Celsius to Kelvin. How do I do that? Well, if I look up here on my equation sheet, it tells me how to convert Celsius to Kelvin. I just add 273. So 50 degrees becomes 323 degrees Kelvin, and N is my unknown. So now it looks like I'm all set to go and plug these into my equation. So N is equal to pressure, which is 700 torr. My volume is 0.855 liters. Notice how I'm labeling these numbers with units. That's what you always should do. My R is 62.36 liters times torr over moles times Kelvin. And then my temperature is in 323 Kelvin. So what are the units of my answer? Well, let's double check and make sure all these units work out. 3 of the units should cancel out and I should be left with just 1 unit as my final answer. So let's check that. Torr divided by torr, check. Liters divided by liters, that cancels out. Kelvin divided by Kelvin, that cancels out. Whoops. And my answer is going to be 1 over moles. So the inverse of the inverse is just moles. Cool. So when I plug this all in my calculator, 700 times 0.855 divided by 62.36 divided by 323, I will end up with an answer that is in moles. And so I get 0.0297. I have this rounded to 3 sig figs. That is based on my volume here, and my temperature. It looks like we're both to 3 sig figs. But mainly my volume, I think, is the one limiting that. So that is my number of moles of gas in that sample. All right, let's take a look at another problem. In this I'm going to go through the same steps. I'm going to identify what it is I know. So in this case, I'm given moles. So N is 5.0 moles. My temperature is 25 degrees Celsius. And my pressure is 2.3 atmospheres. The question is, what volume would a gas occupy under these conditions? So again, this looks like a job for PV equals nRT. The one thing we haven't written down yet is R. So let's look at what R value we want to use. Notice that my pressure this time is measured in atmospheres. So if I look up at my equation sheet, I want to use the R value that is in atmospheres. So this time I want to use this R value, 0.08206. So my R value, again, this from my equation sheet, is 0.08206 liters times atmospheres divided by Kelvin times moles. And I want to rearrange this equation to solve for V. So V equals nRT over P. And let's make sure our units all match up. So my pressures and atmospheres, that matches. Notice how I need my volume to be liters. Right now it is in, what was my unknown? Cool. Okay, and then my temperature needs to be in Kelvin. So I need to add 273 to convert this to Kelvin. So that ends up being 298 Kelvin. And now I think all my units match up. Let's check. So N is my moles. That's 5 moles. We got just 2 sig figs there. Keep that in mind. My R value is 0.0. I'm actually going to write this underneath. I'm going to run out of space. Okay, so it's 5 moles. And then my R value is that 0.08206 liters times atmospheres divided by Kelvin moles. My temperature needs to be in Kelvin, so 298 Kelvin. And then my pressure is 2.3 atmospheres. That's also in 2 sig figs. So that should give me a volume. Let's double check. It looks like atmospheres divided by atmospheres cancel. Moles divided by moles cancel. Kelvin divided by Kelvin. What am I left with? Liters. So when I plug this in my calculator, I should get an answer that's in liters. I'm going to round it to 2 sig figs. So my answer is 53 liters. Okay, let's look at one other example. I'm going to scroll down and look at an example where we are given a grams. So in this problem, let's again go through and write down what we know. We're given a mass this time, which is 5.0 grams of argon. And I kind of erased, there we go. And then we have a volume is 500 milliliters. I'm going to stop and convert that into liters because I've learned my lesson that this should be in liters. Okay, so that's 0.5000 liters. I still want to write it with 4 sig figs because that might be important later on. I'm also given a temperature. So temperature is 20 degrees Celsius. I'm going to convert that into Kelvin. So that's 293 Kelvin. And then I want to know the pressure. So this again is kind of looking like a job for PV equals nRT. And if I want to find the pressure, it's going to be nRT divided by V. So I know temperature and volume, but notice how I don't actually know N yet. I'm not given moles this time, I'm actually given mass. But I also know that I can convert from mass to moles. So I'm going to look up at the periodic table, I'm going to say, what's the molar mass of argon? And argon, every 1 mole of argon weighs 39.95 grams. So if I know grams, I can actually find moles of argon. So that's going to be 0.125 moles. I'm going to round it to 2 sig figs. So that's 0.13 moles of argon. And I need an R value. I want to choose the R value that matches my pressure unit. So it looks like where's my pressure? Oh, my pressure says, my pressure is my unknown. That's what I'm trying to solve for. But the question asked me to solve it in atmospheres. So I'm going to use the R value that's in atmospheres. That's this one, 0.08206 liters times atmospheres over Kelvin times moles. You could also write it this way, liters, atmospheres, K minus 1, moles minus 1. But I like writing it out like a fraction. I feel like that's easier to understand what's happening there. So, okay, so now let's go plug these into our equation. So pressure equals moles, which is 0.13 moles. R is 0.08206 liters times atmospheres divided by kelvins times moles. Let's see, our temperature is 293 Kelvin, and then our volume is 0.5 liters. And it looks like we're going to have two sig figs in our answer. And let's check our units. Moles cancel, kelvins cancel, liters cancel. So the units of our answer are going to be in atmospheres. And when we plug this into our calculator, we should end up with 6.0 atmospheres, I believe. There we go, rounded to 2 sig figs. Okay, hope that helps. Look at a few examples of this. Let me know what follow-up questions you have.